Is space infinite or finite? I mean, how big is space? Okay, that's what we're going to deal with. And in order to get there, I'm going to start with some questions or some issues that a fellow raised. And I answered him last week, but he still didn't get it. So he came back for more, I guess, more punishment. Okay, and so here goes. This is what he had to say. Says, so water is not a thing because it has no shape. You're wrong again. Okay, is water a thing? Well, let's find out. Here's a blob, okay? And you can see the astronaut has just thrown that blob of water or whatever that liquid is, whatever fluid you've got there. And the question, you can think of it as water, right? A drop of water. And the question is, does that drop of water have shape? And hopefully your answer is yes, because that's the rational answer to what you're seeing in front of you. That blob has shape. Now you might say, well, what is the shape of the blob? And the issue is that that's not the question. The question is not what is the shape of the blob. The question is, does the blob have shape? In other words, it's a yes or no type of question. Water does have shape. And you can throw it in, out there in space, a bucket of water. Take an astronaut and he throws a bucket of water, and that water just splashes out there. And you take a snapshot at a given moment, anytime, no problem. You take a snapshot. When you look at the snapshot, you got a picture there. It's a still image. Does something appear in your photograph? And if it does, well, that's shape. It means water does have shape. Okay? And so you can't say that water does not have shape. So water is an object because it has shape. And you had people like Ayn Rand who thought that liquids or fluids in general were not entities, as she called them, objects, things, because I guess in the back of her mind she couldn't figure out, well, that doesn't have shape, so it's probably not a thing. Anything that's made out of atoms had better have shape, because every atom has shape. You have all these things with shapes, and you build this other thing, a table, a chair, a rock, whatever, and that has shape. Anything that has shape is an object, period. We're done. So yeah, water does have shape. Okay, so this fellow thinks that it doesn't have shape because, it's too fluid. He can't tell what shape it is. It's not the question of what the shape is. It's the question, does it have shape? It's a yes or no type of question. Okay, he continues, says, the ether is the field. It's a real substance, just like water is. Who cares about the word field? It's only a word. We know there is something there for electromagnetism and gravity. And so he continues on his rant. And the issue is, is a field a thing? And he thinks it is because this is how he was educated at the monastery, obviously. These people think that energy, field, wave, ether, plasma, they think all these words represent objects. And they don't. They represent concepts. And it takes a mathematician or one of these folks 100 years to understand that. They don't understand that, and when you get into those things, they say, oh, you're doing semantics, you're doing word salad. And that's exactly what he accuses me of. He says, your ropes are invisible too. Yeah, they're invisible. So what? Like I said, it has nothing to do with visibility or touchability. It's got nothing to do with intangibility or, whether we can touch it or see it. And pure assumption, hopefully. We begin with assumptions in science. We said, let us assume, that God exists. And we don't care if he's invisible or not. We just make an assumption that he exists, And so he says, so no better than the ether. No, it is better than the ether because the ether is a concept. That's the difference. The ropes are, take a rope. And here, let me show you one because apparently he's never seen a rope. He's never been to a hardware store. Here's a rope. Does it have shape? Does this item I have in my hand have shape? Hopefully the answer is yes. Okay, it has shape, therefore it's a rope. And each one of the threads, we'll call the red and the blue ones, each one a thread. Each thread also has shape. A 3D, etc., etc. So threads, ropes, cables, wires, coaxials, all have shape. All of them. So all are things. Ether is not a thing because ether doesn't have shape. What does ether look like? Well, let me show you what ether looks like. First, let me show you this. This is what the ether is, okay? There's a bunch of particles moving around, okay? So what is the ether? Is it the black stuff? Is it the white stuff? If it's the white stuff, what's the black stuff? Or is the white stuff the same thing as the black stuff? And you know what these people usually do is say, well, Bill, that's not the ether. And that's the answer I always get from etherists. They always tell you what ether ain't. They never tell you what ether is. That's what I want to know, okay? So if you don't like my ether, you tell me what the ether is. And hopefully you don't define it. Hopefully you point to it, okay? If you define, it's a concept. If you point, it's an object. So you have to tell me if ether is an object or a concept. Can you point to the ether and say that's ether? Like you would point to a rock or to a tree or to a house and say that's a house. That way the ET understands your language. You know, the ET doesn't know your language. You come here and you got to teach him the nouns. And you got to say, look, that's a house, that's a tree, that's a rock. Now he learns your language. He knows what you're referring to every time you say rock. Likewise, you know, we say rope. We point, say rope. No problem. Thread. You point thread. You know, you can point to a needle with a thread coming out of it and say that's a thread. That's no problem. Everybody understands that. What do we point to when we say ether? That's the question. If you can't point and say ether, you can't show me a thing in front of you, then then ether is not a thing. Okay, and so this is what they define it as. Okay, couple fellows there says we may say that according this is Einstein, to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, right, space without ether is unthinkable. So space-time was the same thing as ether. What is space-time? 4 number lines, which they call coordinates or dimensions or something like that. 4 number lines, that's what space-time is. And they say that's equal to the ether. So is that what the ether is? If I ask this fellow, are you going to define it as 4 number lines? Is that what the ether is? And then we have another fellow, he's a Nobel Prize winner, right? The modern concept of the vacuum of space, confirmed every day by experiment, is a relativistic ether. But we do not call it this because it is taboo. Yeah, that's the issue. The issue is they treat it as an ether. All they've done throughout the years is change the name. They called it space-time. They call it first they called it the ether, then they call it space-time. Today they call it the false vacuum or whatever. And they're always talking about the same thing. And they're talking about particles. That's what the ether was always. Many particles filling space. It was the air. That's what ether means. It's the air. Ether is another word for air. But this was the air of the gods. And so what was air? Well, they imagined it as a bunch of particles. And so what is the ether? A bunch of particles. They were just godly particles. That's the only difference between air and the ether. Okay, and so this special air was kind of outside and it was handled by the gods. They could see it, but we couldn't. And so they used the word ether to refer to that. And everybody after that also treated it as a bunch of particles. Newton treated it as a bunch of particles. Huygens treated it as a bunch of particles. They all treated it as a bunch of vibrating particles. That's what they imagined. And so when these people say, well, that's not the ether, then what is the ether? According to you. You got to tell us. You're giving the presentation. You're giving the dissertation. You got to tell the crowd what you mean by ether. You can't just say, oh, the ether. And this fellow says, oh, the ether is the field is the ether. Great. Here, when you look up the ether, and I challenge you to do this, okay? Go to Google and do a Google search on images, and you'll get something similar to what I got here. That's the ether, okay? All those are different versions of the ether. So the question is, what is the ether? Nobody can tell you. Nobody can show you a picture of the ether. Okay, they say, well, let me explain it to you. Let me define it. And so we have a problem because if ether is going to be used as a physical object, you're going to say the ether vibrates or something along those lines, or it moves the wind or whatever, or it's gravity or whatever. Then you have to point and give me a picture. You get a still image before you move anything. Show me a picture of the ether. And if you can't do that, ether is not an object. And you can say, well, it's infinite. No, there's no infinite object. All objects are finite. That which has shape. See how simple it was? You should be able to give me a picture of the ether. If you can't give me a picture of the ether, then ether is a concept. And if it's a concept, you have to define it. You have to tell the crowd what you mean by the word ether. Very simple. Okay? And so these people don't do that. Okay, so this fellow continues. He says, you're deliberately ignoring real mechanisms because you're indulging in what? Stupid word salad. You're being ridiculous. Okay, thank you. Faraday knew there was something there. Real physical, not just concept. Yeah, if it's something, something is something that you have to illustrate. You have to show an image of. So Faraday never defined the word something, but, if he thought there was something there, he left it in the open because he said, I don't know what's in there, but there's something in there. He did say that. So what? I mean, we need to find out what that something is. And it's up to the person giving the presentation to tell the crowd what that something looks like, if he's going to talk about something. Okay? And he said it's not a concept. Well, you got to define what something is and what a concept is. Unless you tell us what your definition of something and concept are, we have no idea what you mean when you say concept, when you say something. Just that simple. It says, call it a field, call it the ether, or 0-point energy, or the bgaede. I don't care. You're completely irrational. You cannot be reasoned with. I have nothing more to say to you. Yeah, and that's what these people do. They run away. They escape because they can't tell you what the ether is. They get frustrated. And they say it's like a field. Well, what's a field? Here's the field. Let me show you the field now, okay? Ether is like a field. Okay, here's the field. Okay, there's your field. That's what people have in mind, some kind of three-dimensional spider web that is shaking, and they say, oh, that's the field. Okay, so what is that? What are we staring at? And again, these people might say, well, that's not the field, Bill. Okay, so what is the field? If you look it up, you find a definition, you don't find a picture. What you find is a definition. The definition is values. Values at each point in space. So they're talking about numbers. It's a mathematical concept. That's what field is. So you can't say that a concept such as love does something. Love moves mountains, not in physics. Okay, you can't say love moves mountains in physics. A heart might be able to move a mountain because a heart is a thing, but not love. And these people confuse field with an object. And they think they're talking about a thing. Okay, and they say, oh, this thing is vibrating. This thing called field. And so he's saying something in there is moving. Yeah, that something is what you have to identify. And it's not the field. The field is infinite, remember. A magnetic field and an electric field, they extend forever. That's what the official version is. That's why you have to clarify. If you don't like that, you have to clarify it. But right now, the official version is that a field extends forever. There's no object that extends forever, therefore a field is not an object. In fact, a field is just a bunch of numbers with decreasing values, decreasing strengths away from ground zero. That's all it is. Just numbers. It's a mathematical concept. If you say there's something physical in there, you got to identify that physical thing, give it a name. Can't be the field because the field is the whole shebang, right? So you got to say what it is that is vibrating inside that region we call field. Okay, so that's the way it works in science. Okay, so here we have field. Look it up, and it says a physical quantity that has a value for each point in space and time. So it's a bunch of numbers that are vibrating. That's what they do. They vibrate numbers in mathematical physics. And this is what these people think are physical objects. So they treat the word field as a physical object. And they get upset when you point that out to them. You say, oh, you're doing word salad. You're doing semantics, Okay, so here we have, but he said the ether is the field is the ether. But here you can see that they're very different. The ether is the one on the left, field is the one on the right. They don't look the same. And again, the guy says, hey, you're making fun of me. Yeah, but see, it's up to them to tell the crowd what the field is, okay, and what the ether is. You can't continue, using these words like they use them now, which is, as concepts that they turned them into objects. They reified these concepts. They concretized them. They made them concrete. And they don't realize that. They don't realize that they're dealing with a language that was given to them by the mathematicians, whom they criticized, by the way. The electric universes, they use these concepts as well as physical objects. Where did they get the language? Where did they get the word plasma? They got it from the mainstream they criticized. So if you don't like the mathematical physics because you say, oh, that's irrational, then you can't use their language. If you're going to use their language, you're going to run into trouble because their whole language is screwed up for the last 100 years. That's why they don't have any rational explanations for anything, for any phenomena. Okay, so what does this fellow do? He says, but you're asking me to define words scientifically, Bill. That's word salad, just semantics. Yeah, when you ask them to define words, they don't like it. They say, hey, you're doing something that is not scientific. I came here to do physics, they say, not to learn English or to do grammar or semantics or ontology or any of that. So this is the problem, okay? Okay, give me a second here. Okay, so here we have field, okay? Another fellow, he says, what if the field was a range of potential quantum positions of a thread? You can't mix the rope model, the thread, right, with anything in quantum. Quantum talks about particles. In other words, discrete entities which are not particles either, but they use the word particle to mislead you. They say, oh, particles. No, they're not talking about particles. But what they're referring to, because, that's what they use in mathematics, they're referring to values, discrete values. So they say there's a value here, there's another value here, another value here, and the whole shebang we call a field or whatever, okay, or energy or, or mass, right? But quantum mechanics deals with discrete things. Why? Because they can put those values in an equation. You can't put a rope in an equation. You can't put a thread in an equation. Okay. In fact, you can't put a particle in any equation, a corpuscle, right, or a dot. No, you have to put a number, and that's what the word particle means in all of mathematical physics. When they use the word particle, they're referring to values, to amounts followed by units. That's what a particle is to a mathematician. They don't know anything about objects, about things. That's why they never defined the word object anywhere in physics. Just get any. Take my word for it. I'll give you a beer if you can find any textbook on planet Earth of physics, right? Secondary school, high school, college, that begins by defining the word object, what a thing is. You won't find it. No one in the last 2,000 years discovered, in physics, right? Discovered, researchers, theorists, discovered that the first word you need to define in physics is the word object. You can't do physics without objects. If there were no objects in the universe, what's happening? What are you staring at? What are you experimenting with? What are you seeing? What's happening? Nothing. You need objects. And they never realized that. Why? Because all they do is math. They do descriptions of movement. And that's what an equation is.